Section 5.3 is going to focus on the graphs of sine and cosine. First thing, it's important to know that the graphs of these functions are not the same as the unit circle. The unit circle is just a calculator that we have in our head to calculate some trig values. The actual graphs of them are very different. Both sine and cosine have a period of 2 pi. That means that's how long it takes for it to finish one of its cycles. They are called periodic functions because they repeat themselves. It makes sense that it's 2 pi because once we go around the unit circle full time, we have one full period, and then everything starts to repeat itself. So it takes 2 pi for it to finish itself up. The graph of sine, we're going to look at here. What this is going to do is I'm going to be increasing the radians. So this is the unit circle over here. And what this is going to graph is the angle on the x and the sine of that angle on the y. So actually, let me just put it here. So just so we know what it is that it's graphing the radian angle and then the sine of that angle. And as I rotate around the unit circle, well, at 0 radians, the sine is 0, so you can see this dot is here. As the angle starts to increase, the sine starts to increase until it peaks at 1. But then the sine starts to drop, and at pi radians, or 180 degrees, we're back to 0. And then sine is negative in the third quadrant until it bottoms out at -1. And then finally, it comes back to 0, and there's one full period of sine. And again, it is a periodic function. It would keep repeating that wave over and over and over again. Now, we're not going to plot all the individual little dots because it would take too long. Basically, we care about when the sine is on the midline, in the middle, or when it peaks or valleys. So for our general graph of sine, it took 2 pi for it to finish its cycle. The important angles were, I'm going to slice that in half, that's pi, and then pi over 2 and 3 pi over 2. Those were the important angles going around the unit circle where the sine was either 1, 0, or -1. Again, we saw from the graph, it peaked at 1 and it valleyed at -1. Sine started in the middle at 0. At pi over 2, it was up at 1. At pi, it was back to 0. At 3 pi over 2, it was down to -1. And at 2 pi, it was back to 0. And so then I try to make a nice fluid looking wave. And there's one period or one cycle of the sine wave. Now we're going to look at cosine's parent graph. Now this one does in degrees, but it's the same logic. At 0, the cosine is 1. So notice that this dot is starting up at 1. And then cosine diminishes until it reaches 0 at pi over 2, or 90 degrees. Cosine becomes negative in the second quadrant until it bottoms out at -1 at pi, or 180 degrees. Cosine's still negative in the third quadrant until it reaches back to 0. And then cosine in the fourth quadrant goes back to positive until it reaches back up to 1. So for cosine, again, this is in degrees, but we're going to do it in radians. I'm going to split up the graph, the x-axis, the exact same way that I did for sine. I've got 2 pi. I split that distance in half. That's pi. I split each of these halves in half. Pi over 2, 3 pi over 2. Just like sine, it peaked at 1 and it bottomed out at -1. But cosine started above the midline. And then it was on the midline, then it was down below, then back on, and then above. And you get this kind of U-looking shape for one cycle of cosine. So those are your parent graphs for sine and cosine. Now, just like every other graph we've dealt with in algebra, pre-calculus, all your classes you've taken in math, we have to be able to transform these graphs, which is what we're going to learn in just a little bit. Before we get to that, though, one important thing is that the sine and the cosine wave are actually the same image, just moved. Don't draw this, but if I continued cosine back here, because again, remember, these do repeat over and over again. If I drew another cosine, another cycle of this, now I drew it kind of small, but if I look at just this window here, that's the exact same thing as sine. It's just been moved over. So sine and cosine waves are really the same image, just shifted over from one another. Okay, so some important properties of these. The domain is -infinity to infinity. You can always keep going left and right forever. Again, these waves repeat themselves over and over again. The range, however, is very limited, at least on the parent functions. It's from -1 to +1. The amplitude is the distance from the midline. So it's how far from the middle to the top of the wave or to the bottom. That is the absolute value of A, which is going to be the variable that we'll look at in just a little bit farther down in the notes. The big thing with amplitude is that it is a distance, so it has to be positive. Distance is positive, so that's why I have absolute value there. The difficult part of graphing these is finding the period. So the period is based off of this k number that's being multiplied to x. It's inside of there. So before we start figuring out the period, here's what basically happens. If I have, we'll go with sine, a normal sine function. Normal sine function I know is going to finish the wave, which is going from the middle, up, down, back to the middle. That's one sine, and it took a 2 pi to finish that. The period is 2 pi. If that was sine x, then if I did sine of 2x, that 2 means that I'm going to finish 2 sine waves by the time I reach 2 pi. So what is that going to look like then? That means I'm going to have 2 sine waves by the time I reach the 2 pi. That means that it finished its wave after only 1 pi. So its period is pi. If I had something like sine 4x, that 4 tells me I'm going to finish 4 waves by the time I reach 2 pi. So that's going to look a little funky. I've got to finish 4 by the time I reach 2 pi. So I'm going to have 1, 2, 3, 4. Again, I know it's looking a little nasty here, but looking at just the blue, here's where that blue finished a cycle. Its period then would be pi over 2. Vice versa, if I had sine 1/2 x, that half means I'm only going to see half of the wave by the time I reach 2 pi. So what is that mess going to look like? Let me erase some of this other stuff. That means that I'm only seeing half the wave by 2 pi, which means it took all the way to 4 pi to see the whole wave. So what does all this end up meaning? This ends up meaning that the period is 2 pi divided by whatever that k number is, which we'll do in several examples throughout this lesson. Okay, so how are we going to graph these? Well, we're going to figure out kind of the important information. We're going to figure out the amplitude. We're going to figure out the period. We're also going to figure out the increment on there, increment length on there as well. We're going to figure out if there's a horizontal shift and if there's a vertical shift as well. There's always an amplitude, there's always a period. There may or may not be shifting. We're going to basically split our axis into 4 intervals. We're going to plot the key points and draw the graph. Okay, so I like to write down what's going on all of these off to the side, and I suggest you do it as well. So on number 1A, I want to figure out the amplitude, the period, and off of the period is always the increment. So I like to do this, increments, because it's a part of the period or it's based off of it. And then I'll see if there's any horizontal and vertical shift in just a second. So amplitude is the number in front. It basically is the vertical stretch. I have a 3 multiplied to this, so that means this has an amplitude of 3. The period is based off of whatever's multiplied to x. Technically, it's just a 1. So I take the normal period, which is 2 pi, and I divide by 1. That's just 2 pi. So it's the normal period of a sine function, 2 pi. We always take the period and we divide by 4 to figure out the increments. We're always going to split these into 4 parts. So 2 pi divided by 4 is my normal increments of pi over 2, which we saw on our parent graph. So this graph is going to be basically on the x-axis, it's going to be just like it was on the parent, 2 pi. I slice that in half. I slice each half in half. Each increment on the axis is pi over 2. So again, we have pi over 2 plus pi over 2, which is pi, plus a pi over 2, which is 3 pi over 2, and finally 2 pi. What's changing is the amp. Instead of going up 1, down 1, I'm going up 3 and down 3. And on every time that you graph one of these for a quiz or exam, I'm going to say label the increments on both axes. So I want to see this. Now notice I did all of this work without ever actually looking to see if I was doing sine or cosine, because all that work is regardless of sine or cosine. So now I see, okay, it's a sine graph. Sine starts on the midline, and then at the next increment it goes above, and then back on, then below, and then back on. And then I just try to connect it in something that looks kind of like a wave. And there we go. And again, I want you to remember that this does repeat itself over and over again. So here is actually sine. If I take that A number and I turn it up to 3, I can see that all it does is vertically stretch it. It amps it to 3. This is in normal integer numbers, but 2 pi is about 6.28, so that is where it's finishing. And I can see there's one cycle of sine. For letter B, I'm going to write down my important information, amp, period, off of the period, the increment, and then we'll see if there's anything else. So the amp is what's multiplied. It's the vertical stretch, essentially. So there's a 2 multiplied to cosine, so it's an amp of 2. There's nothing multiplied to the x, so the period's the normal 2 pi. I divide that by 4 to get my increments of pi over 2. Now, this one also has a plus 3 on it. That is a vertical shift. So this has a vertical shift of, you can write plus 3 or up 3, however you want to do it. So before we set up our graph, let's think about what that vertical shift does. That's going to move the middle up 3. So normally the middle is at 0. The middle is going to move 1, 2, 3. So this is going to be the middle of the graph. And from that middle, my amp is 2. That means I'm going to go down 2 to 1, and I'm going to go up 2 to 5. So this graph is going to exist above the x-axis. So I'm going to set up my graph a little different. My x-axis is not changing. It's the same 4 increments as it was on the previous problem. But again, on the y-axis, my midline is up 1, 2, 3. And then I'm going to go 2 from there. So I'm going to go down to 1 and up to 5. So my graph is going to exist between 1 and 5. Since my midline changed, by the way, I like to put a little dotted line to signify that that's my new middle. And again, I did all of this information, or I attained all this information without caring if it was sine or cosine. Now I go, all right, it's cosine. Cosine starts above the midline. That's going to mean all the way up at 5. And the next increment is going to be on the midline. Then below, which means down at 1, then back on, then above. Notice that they cycle. If they're above, the next one they're going to be on. If they're below, the next one they're going to be on. And I get something that looks like that. And again, to show this more precisely, this is a cosine graph. My amp was 2. And my D number was 3. Again, notice that all that's doing is just shifting the whole graph up. Notice that it exists between 1 and 5 this time. For letter C, I'm always going to have amp and period, and then I build increment off of that. Now this one, be careful. My amp, that's the number multiplied out in front. You might think, oh, -1. But remember, amp is a distance. So the amp is still 1. That negative, remember back to algebra, that's going to reflect it over the x-axis. The way I like to signify that, and this is not a standard, but I like to draw a little arrow like that. That just reminds me, oh, I've got to flip this graph. This one is the first one that changes the period. I have a 6 multiplied to x. To figure out my period, I take 2 pi and I divide by that number. So that's going to give me a period of pi over 3. So this is the first time we've had the period change. Now I take the period and always divide it by 4. So I'm taking pi over 3. If I divide that by 4, that's the same thing as multiplying by 1/4. And so my increments are every pi over 12 this time. Kind of a weird number. Okay, so I've got all the information I need to start setting up my graph. There's no vertical shift, so I'm going to put it right down the middle again. Now, this one is going to finish its cycle at pi over 3. I always take the period, slice it in half, slice each half in half. But now each one of these increments is pi over 12. So the first one would be pi over 12. Pi over 12. The next one, I would add another pi over 12. So 1/12, 1 pi over 12, plus another 1/12 is 2/12, or pi over 6. Then I would add another pi over 12. That's 3/12, or pi over 4. And if I added another 1/12, that's 4/12, which is pi over 3. On my y-axis, my amp is just 1. This is definitely not going to be drawn to scale. Oops, I did not want to erase that. I also didn't want to do that. There we go, we're back. 1, -1. Okay, now I go, all right, what am I graphing? I'm graphing sine. Sine starts in the middle. Normally sine goes above, but remember this has that negative, which is going to reflect it. So it's actually going to go down below, back on, above, back on. So I get a reflected sine, and it's finishing its cycle at pi over 3. So this has actually been compressed horizontally, and you'll see through this what I'm talking about. So on this one, my amp was my amp was 1, but the A number itself was, the amp was 1, but the A number is -1. I didn't have a vertical shift. But in ours, we called it K. On my graph here, I call it B. That number was 6 this time. Actually, I think mine only goes to 5. Right. Mine only goes to 5, but you can see that what this is doing is kind of slinky smashing it together. It's finishing its cycle much faster. And you can see that it is reflected. It's going down first. For letter D. All right. Again, let's figure out our information before we try to graph anything. Amp, period, off of the period, find the increments. All right, my amp is, again, the absolute value of the A number, which is the number out in front, or multiplied out in front. So the amp on this would be 1/4. But again, it has a negative, which means it's going to have a reflection. The period, okay, careful. People will think, oh, that's the period. No, that number influences the period. But I've got to take the normal period, which is 2 pi, and I divide by that K number. So if I divide by pi over 4, that's the same thing as multiplying by 4 over pi. Pi's cancel, and I'm left with 8. Now that may sound bizarre, but the period does not have to have pi in it. Sometimes it does, sometimes it doesn't. I always take the period and divide by 4 to figure out my increments. So my increments are 2. No vertical shifts or anything, so I'm ready to try to graph this. So this is going to finish its cycle at the number 8. Always slice the period in half, slice each half in half. Every increment here is 2, so that's simple enough. 2, 4, 6, 8. The amp is only 1/4, so I'm only going up 1/4 and down 1/4. So again, not really drawn to scale, but I am going to try to make it look a little flatter. So up 1/4, down 1/4. And again, I'm not worried about you having drawn to scale. As long as you label, we're fine. All right, so I'm set up. This is a cosine. Cosine usually starts above the midline, but that reflection is going to make it flip, and it's actually going to start below, and then on, then above, on, below. So I get kind of a smushed little cosine wave that's been reflected. So again, let's look at what this is. My A number was -1/4, so -0.25. I can't get exactly pi over 4 on this, but pi over 4 is going to put me pretty close around here. Pretty close to right around there. Here's 8. I can see I get a tiny little wave that finishes its cycle